Hi everyone, this is an example of balancing an equation using oxidation numbers. Here I have an unbalanced equation. Iodine solid reacting with a ClO3 negative ion to produce an IO3 negative iodate ion and a chloride ion. To balance this equation, I have these steps to follow. Assign oxidation numbers to everything, look for the change in electrons, balance the electrons, balance by inspection, add in hydrogen ions or add water as needed. I might feel tempted to just dive right in and immediately start to balance by inspection. By that I mean I might feel tempted to go I2, don't I put a 2 there? No, we have to fight that temptation. We have to go through this complete process. The first step of which is assign oxidation numbers to all of the substances in our equation. I2 solid, that's an element. It has an oxidation number of 0. ClO3, 1 minus. Oxygen is -2. There's 3 of them, -2, -4, -6. One chlorine in there, its oxidation number is going to make it so that they add up to -1, which means the chlorine here is +5. On the product side, IO3 negative, the oxygen is -2. That means the iodine, just like the chlorine on the other side, is a +5. And these chloride ions, it's a simple ion. I can see the charge. The oxidation number matches the charge. First step, assign oxidation numbers to everything. Now look for the change. The iodine went from 0 to 5. 0 to 5. That's a change of 5 electrons. The oxidation number went up, it got oxidized, and the change in the oxidation number was 5. That's the change in electrons. The chlorine went from +5 to -1. +5 to -1, that's a change of 6 electrons. Step 1, assign oxidation numbers. Look for the ones that are changing, which I've done. Now I need to double check, be on the lookout for subscripts. This I2, there's the subscript, it has a 2. The oxidation numbers that I was assigning were for individual atoms. But here I have 2. The change was 5 for one iodine, but there's 2. It was 5 electrons per iodine, but there's 2 of them. Was 10 electrons per I2. With the chlorine, it doesn't have a subscript right there, so I don't have anything extra to worry about in that regard. My next step is to balance the electrons. 10 and 6, the lowest common multiple of 10 and 6 is 30. So here I have to multiply by 3, and here times 5. Whatever it is that I'm going to multiply by, that becomes the coefficient. Here we're multiplying by 3, so that becomes the coefficient. Here we're multiplying by 5, it becomes the coefficient. Once we have those numbers in there, we can balance the rest by inspection. This is 6 iodines. Here's I. Needs a 6 to balance it. Here's 5 chlorines. A 5 to balance right there. The oxygen is next. Here there's 15. Total of 15 oxygens on the left-hand side. On the right-hand side, here there's 18. 6 times 3, 18. 15 oxygens on the left, 18 oxygens on the right. I can't mess with this number because it was based on all this earlier work. To balance the oxygens, introduce water. I'm 3 oxygens short on the left-hand side, so I myself need to go in and add 3 waters. I introduced water here where it was needed. I needed it on the left-hand side to bounce off the oxygen, so I did that. But by doing so, I also brought in 6 hydrogens to the equation. And to balance them, I add hydrogen ions where I need to in order to have things balance. To balance an equation using oxidation numbers, the first step is to assign oxidation numbers to all of the chemicals involved. Then look for the change. Once you identify the change, go back and take a second look to see if any of the substances involved had a subscript. That's going to make a difference. Here, the change was 5 per iodine, but I had 2 iodines, so overall the change in electrons was 10. Once you have the change settled, balance the electrons, and whatever you're going to multiply by, that becomes the coefficient. Once those 2 coefficients are there, we're balancing the rest by inspection. If we need to, we're going to balance the hydrogens by adding hydrogen ions, put them where needed. They could go on either side, put them where you need them. To balance the oxygens, we're going to bring in liquid water and put them where you need it. In the end, we have a balanced equation with 6 hydrogens on either side, 18 oxygens on either side, 6 iodines, and 5 chlorines. And I hope that helps.